Hello friends, so in this video I will be discussing more about differentiation, which I have earlier discussed in part 1. So let's begin. So I will discuss about two things. First is first derivative and the other is second derivative. We will take two examples and see one by one what happens in each of the case. Let's draw a line, straight line. So this is x-axis and this is y-axis. As I already told you that the slope is tan theta, and slope at any point is calculated by calculating the tangent, creating a tangent at any point. So if you take this point and you take the tangent will be the same. So if the tangent is same as the line, then this angle will also be the same as the line which makes with the x-axis. Now, so slope will be tan theta at this point. Say this is one point. This is point 1. Now take another point, point 2. If you make a tangent here, again this is a straight line, so this will be the same as theta. So m2 will again be tan theta. That means the slope at this point and the slope at this point are the same. And I told you the differentiation, that is dy by dx, say at point 1, this is at point, I am saying at point 1, this is equal to m1, as I already told you. So the differentiation at dy by dx at point 2 will be m2. But since m1 and m2 is same, because both have the angle theta and tan theta will be the same, so we can say that dy by dx at point 1 and at point 2 are same. There is no change in the derivative at point 1 and 2. Say we want to find the slope change when the x changes. So that is the second derivative. So basically what we are saying is, instead of saying about that what is the change in y with respect to x, that was the first derivative dy by dx, and this is equal to the slope. Now we will ask what is the change in slope when x changes. So this derivative is called d2y by dx2, and this is because we are calculating derivative with respect to x of dy by dx. That's why this is written like this. This is just the notation. So if you see in this case at point 1 and point 2, at point 1 and point 2, if you see, the m1 and m2 is same, so delta m will be sorry, so delta m will be 0. So if delta m is 0, then d2y by dx2, which is the second derivative, will also be 0. So in the case of a straight line, the slope remains the same at all the points. That means the derivative at each point remains the same. And that's the reason the second derivative becomes 0. Now if you calculate the third derivative also, that is also 0, and so on, in the case of a straight line. Now we will take an example of second case. In this case, now we will see what is happening. First derivative and the second derivative. We are doing the same thing for two cases. First was the straight line. Now we will take something else. Let's take a parabola. We know the equation of parabola is y is equal to x square, ax square, but we are taking y is equal to x square. A is 1 here, right? So basically we can say that if whether the x is, this is x-axis, x, and this is y. So if we take 2 points now again, so this point, if we create the tangent, this will go like this. At this point, tangent will go like this. So this angle will be theta 1 and this angle will be theta 2. So at point 1, this is point 1, this is point 2. At point 1, if we talk of point 1, what is happening? M1 is equal to tan theta 1, which is equal to dy by dx at point 1. Now if you take the point 2, then M2 is equal to tan of theta 2, and this will be dy by dx at point 2. Clearly theta 1 is smaller than theta 2, that is very clear, and so they are not equal. And since they are not equal, so if we calculate the second derivative, which is d2y by dx2, which will be, you can say, delta m by delta x. So this will be something like m2 minus m1 by delta x, and this delta x will be like from here till here. This is delta x, this is delta x. So clearly there is second derivative in this case. In the straight line case, there was no second derivative. Second derivative was 0 because the slope was not changing. But in the case of parabola or cubic or more polynomial functions, the second derivative exists and it is non-zero because the slope changes, slope varies. Now, so there is second derivative. Now mathematically, if we want to see what is the second derivative, what we can do is we can start doing the calculation. Y is equal to x square. So dy by dx will be equal to 2x 2 minus 1. As I told you, for the x to the power n, it is n x n minus 1. The derivative of x raised to the power n is this. So 2 comes before and it becomes 2x. Now if you take the derivative of this one, dy by dx, then this is d2y by dx2, which means you are taking the derivative of dy by dx, again the variation in the slope with respect to x, that is the thing. So now dy by dx, this is dy dx, and dy by dx is 2x. So 2 is constant, it will come out. So it is dx by dx, that is equal to 2. So second derivative is 2. Now if you calculate the third derivative, that will be 0, because second derivative is constant. Because in the straight line case, the first derivative was constant, so second derivative becomes 0. And in this case, second derivative is constant, so third derivative will be 0. But second derivative do exist. So second derivative tells about the how the slope is varying in the function. In the function, any function, it could be straight line, it could be any polynomial function. It is parabola. This case is parabola. I have taken the points like 1 and 2 here. 1 and 2 points. These 2 points, you can see these are very far. This was for illustration purpose, but derivative is always calculated when the points are very near. So if 1 is here, it should be second derivative should be very near. That means the delta x should be tending towards 0. So this was all about first and second derivative, and in the next video I will talk more about this calculus. Thank you.